Thanks, Satya. Now, we all know that security scans can take a while, so I'm not going to do one live. So let me show you the results of an MDASH scan I already ran on my code base. Now, the system runs as a standalone CLI, but today I'm using it in my GitHub Copilot app on my local dev machine. The scan is broken down by vulnerability domains and severity, and it's also finding traditional issues like coding errors and hard-coded secrets. It's also identifying AI-specific vulnerabilities in the code base. Now, what happened under the hood is that over 100 specialized agents are working together to discover, debate, and prove exploitable vulnerabilities end-to-end. And when the scan finishes, it generates both a SARIF log and an HTML report that I can give to my management. Now, the Defender Details command allows me to dig into these vulnerabilities, and I can see what the vulnerability is, where it is in my code, and the severity to help me prioritize. And from here, of course, we're going to fix it. Now, using the Defender Fix command, the system will remediate suggested fixes directly in my local dev environment. And when that's done, I can check out the diff. So I have full transparency about what the harness has done, and I still have a human-in-the-loop check. But, of course, everything I've shown you so far has run locally, but I can also create a PR to plug into my existing workflows and push up to my repo, and I can take the SARIF output from the scan, and I can upload it to tools like GitHub Advanced Security and manage everything alongside my other application security findings. Now, I've shown you MDASH working on my code, but let me show you a vulnerability our security research teams identified using MDASH that you can go and look up yourself. So the TLDR, because this is a lot to read, of this bug is that WASM time reads an out-of-date map of an object, runs off the end, and then it crashes the host. So this is exactly the kind of bug that the harness was built for, because the flaw is spread across 3 different parts of the code base. So no single file looks wrong on its own. They look absolutely fine. And we can even see here, which is probably my favorite part of this bug, a very confident statement from the developers claiming everything is fine. Now, this is exactly the sort of reassurance that fools normal scanners and single AI models. But MDASH wasn't fooled. One team of agents spotted the suspicious gap, another team argued it apart, and a third team built a working example that actually triggered the crash. And it did all of this in an open source code base. And this is the kind of joined-up reasoning that previously required significant manual security research effort. This is MDASH helping developers create secure code from the start, coming soon to your CLI and the Microsoft Defender portal. Back to you, Satya.